Welcome back to Math for Technology. We are moving into section 4 of chapter 5, trig functions of any angle. So one of the terms that we need to know, or the main term in this section, is the term reference angle. A reference angle is any acute angle between the terminal side of theta and the x-axis. To me, the most important term there that I wrote is this term, the x-axis. So we're going to talk about what that means with some pictures. So example 1 says, find the reference angle for each angle theta. Theta is 64 degrees. So we're going to start this just like we did when we were drawing angles in standard position. I have my x and y axis. I'm going to start the angle on the positive x-axis. This is my initial side. I'm going to move 64 degrees, so I'm still going to be in quadrant 1. So this is 64 degrees right here. The reference angle is simply the angle that is created between my terminal side and the x-axis. In this case, that angle created between the terminal side and the x-axis is the angle itself. So the answer to my question, or find the reference angle, it is 64 degrees. The reference angle will always be the given angle if your angle is in the first quadrant. So in first quadrant, the given angle is the reference angle. So that'll make things easier on us. Okay, let's look at 329 degrees. Starting here, I'm going to rotate 329 degrees. 90, 180, 270, so I'm over here in the fourth quadrant. So that's 329 degrees. Now the angle that I'm creating is going to be between the terminal side, which is this one, and the x-axis. So my reference angle is this angle right here. So I have to think about, how can I find that? Well, if I'm given my angle as a positive angle, the reference angle is the difference between that and an entire circle, which is 360 degrees. So to find it, I'm going to do 360 minus 329, which gives me 31 degrees. So in the fourth quadrant, the reference angle is the difference between the given angle and 360. So in short, just do 360 minus theta. Now, of course, this is provided that they give us a positive. If it was a negative, then we'd have to add it. On C, 210 degrees, so I'm starting here, but I can't see anything. Here we go. So here's my initial side. Sorry it's so fat. 210, 90, 180, so I'm ending up in the third quadrant. The angle that I'm looking for is between the terminal side and the x-axis. So it's this angle created right here. Since I went 210 degrees, and I know all the way from the positive x-axis to the negative x-axis is 180, the reference angle is going to be the difference between our angle and 180. So in quadrant 3, do the given angle minus 180. So theta minus 180 degrees will be our reference angle. A, B, and C were all given to us in degrees. D and E are given to us in radians. The process is no different. We just have to think about what does that mean when it comes to adding or subtracting. So 3 pi over 4. Let's think about, before I even go there, let's think about what our quadrants are. In radians, this is still 0. This is 90, but in radians, that's pi over 2. Or you might just think of it as half of a pi. Over here at 180, that is a full pi. Coming down, that's 3 pi over 2, or 1.5 pi. And then around would be a full circle, which would be 2 pi. So these are the numbers we're going to use instead of like 180 and 360. 3 pi over 4, so that's 3/4 of a pi, which is more than half of a pi, but not quite a full pi. When we actually go to look at our angle, we're still starting here, initial side. It's more than a half, but not a full, so we're over here in the second quadrant. The reference angle is going to be the angle created between the terminal side and my x-axis, so that's this piece here. Again, a full rotation is 180, or a half rotation is 180 degrees, or pi in terms of radians. So in quadrant 2, since that's where we've landed, we're going to take pi in this case and subtract theta. Now what this has made me think of is we might want to back up a little bit, and what can we think about these? In quadrant 1, it's the given angle, so that doesn't matter if we're in degrees or radians. The fourth quadrant, we're using 360. Just remember that 360 is 2 pi, so if your answer is in, your given is in radians, do 2 pi minus theta. In quadrant 3, it was theta minus 180. Well, 180 is pi, so in this quadrant you would do theta minus pi. In quadrant 2, we've already just said it was pi minus theta, so if we think about it in terms of degrees, that would be 180 minus theta. So we've gone back and put in, no matter if you're in radians or degrees, you can go ahead and make that work. So in the D that we're doing, since we've decided it's pi minus our angle, we're going to do pi minus our angle is 3/4 pi, or 3 pi over 4. Remember, there's an invisible 1 right here, so think fractions. 1 minus 3/4 is 1/4, so my reference angle would be pi over 4. E, 8 pi over 5, we're again in radians. Still using 0, pi over 2, pi, 3 pi over 2, back to 2 pi. I want to show you this in terms of decimals because I know that might be easier for some people. If we think of 8 divided by 5, that's 1.6. So this term is 1.6 pi. Half of a pi is 0.5 pi. 3 pi over 2 is 1.5 pi. 1.6 pi, therefore, starts here as always. There's half, there's a whole, there's 1.5 or 1.5, so it barely comes into the fourth quadrant. The angle that I'm looking for is here, because it's always between the terminal side and the x-axis. So I've got to find out what that red angle is. For the fourth quadrant, pretty sure we had a fourth quadrant already, here it is. it says to do 360 minus the given angle. So we'll come back down here. So in our case, because we're in radians, we're going to do 2 pi minus the given angle of 1.6 pi. Since they're both in terms of pi, just look at the numbers. What is 2 minus 1.6? Well, that is 0.4 pi. So that is my reference angle. If you prefer the fractions, it ends up being 3, well, let's get rid of that and I'll show you the fractions. So 2 pi, if I leave it in 8 pi over 5, I have to have common denominator. So that would be 10 pi. 10 divided by 5 is 2. 10 pi over 5 minus 8 pi over 5. 10 minus 8 is 2. So it ends up being 2 pi over 5. That's our reference angle. Now we've already looked at sine, cosine, tangent, and so on, but we haven't actually looked at how it looks if we lay them all out. This picture that you're seeing in front of you now, what it's discussing is if the ratios are positive or if they're negative and how that changes as you move throughout the quadrants. In quadrant 1, they're all positive. So all 6 trig functions are positive in quadrant 1. In quadrant 2, the only positive ones are sine and cosecant.